Welcome to the next topic, trigonometrical identities. So this is the first chapter of the unit trigonometry, and you all have studied trigonometry in class 9th. So this chapter is taking that topic ahead, and it is the trigonometrical identities that we are going to focus on. Okay, so let's understand what is this trigonometrical identities all about. You all know that trigonometry is the science or mathematics which deals with the measurement of angles or sides of triangles. Measurement of angles or sides of triangles. Okay. Now there are six trigonometrical ratios. Six trigonometrical ratios relating to the three sides of a right angle triangle. You all know these ratios from class 9th. These ratios are sine, cosine, tangent, cotangent, secant, cosecant. Sine, cos, tan, cot, sec, cosec. These are the six trigonometrical ratios which gives you which is equal to the ratio of two sides of a triangle taken in a particular order. Okay, so let me give you a mnemonic which I've already discussed in class 9th, but those who are new students, they will know this mnemonic. Here I'll tell you: so ka toa. It is known as SOHCAHTOA. So means SOH. That means means sine is equal to opposite upon hypotenuse. Okay, so suppose this is the angle which we are considering, with respect to which we are finding the sine ratio. So the sine ratio of this angle A is opposite upon hypotenuse. Now this perpendicular which you see, we call it opposite, and the base remains base and the hypotenuse remains hypotenuse. So sine of angle A is opposite upon hypotenuse. Opposite is BC and hypotenuse is AC. So BC upon AC is sine A. Similarly, cos is adjacent upon hypotenuse. Okay, cos is adjacent upon hypotenuse. Now this base is known as adjacent. Okay, so AB upon AC, that is cos of angle A. Cos with respect to angle A is AB upon AC. Then comes tan. Tan is opposite upon adjacent. Tan is opposite upon adjacent. Opposite is BC, adjacent is AB. BC upon AB is tan. Tan of A is BC upon AB. Tan of angle A is opposite upon adjacent, BC upon AB. Okay, after tan we have cot. Now cot is the reciprocal of tan. So if you write cot over here, you can understand cot is adjacent upon opposite. Adjacent of angle A is AB and opposite is BC. So AB upon BC is cot. Sec is reciprocal of cos, which is hypotenuse upon adjacent, which is AC upon AB. Cosec is reciprocal of sine, which is hypotenuse upon opposite, which is AC upon BC. So this is how you get the values of all trigonometric ratios with respect to a particular angle in a right angle triangle, right? So we have studied this in detail in class 9th. Always remember SOHCAHTOA. Okay, great. Some important things to understand about trigonometrical ratios. Each trigonometrical ratio is a real number and has no unit. Okay, trigonometrical ratio is a number, it has no units. Okay, the values of trigonometrical ratios are always the same for the same angle. In right angle triangle ABC, sine of angle A is BC upon AC. Sine of angle A in right angle triangle AMN is MN upon AN. Now, these two triangles, ABC and AMN, are similar triangles. And we know that for similar triangles, the corresponding sides are in proportion. So, the ratio of corresponding sides will be equal. So, uh, BC upon AC is equal to MN upon AN for right angle triangle ABC and AMN, which are also similar. So, as you can see in two similar triangles, the trigonometrical ratios have the same value, right? So, that's one important thing to understand. Although it has no direct applications in this chapter is all about trigonometrical ratios, identities. Now, let's go to some more relationship which we have studied in class ninth regarding trigonometrical ratios. The first relationship is reciprocal relation. So, to understand reciprocal relations, you must understand SOHCAHTOA. As I told you, uh, sine is reciprocal of cosec, cosec is reciprocal of sine. You can see over here, sine A is BC upon AC and cosec A is AC upon BC. So they are both reciprocal of each other. Similarly, cos and sec are reciprocal of each other, and tan and cot are reciprocal of each other. Okay, so the final formula which we have is sine A is 1 upon cosec A, cosec A is 1 upon sine A, cos A is reciprocal of sec A is reciprocal of cos A, tan A is reciprocal of cot A is reciprocal of tan A. Okay, please remember these reciprocal relation. Along with reciprocal relation, there are quotient relations as well. See, we know that I will talk in the language SOHCAHTOA so that you understand. Sine of any angle is equal to opposite upon hypotenuse. Cos of any angle is adjacent upon hypotenuse. If you do sine upon cos, what do you get? You get opposite upon hypotenuse upon adjacent upon hypotenuse. This gets cut and you get opposite upon adjacent. Oh, opposite upon adjacent is tan. So sine upon cos is nothing but tan. Sine upon cos is nothing but tan. Okay, now can you guess what will be cot? So cot will be the reciprocal of tan. Therefore, we can write it as cos upon sine. Cot, the trigonometrical ratio of cot is cos upon sine. So tan A is sine A upon cos A and cot A is cos A upon sine A. So this is quotient relationship. Square relation, one of the most important relation used very frequently in trigonometry. If you find the square of sine of an angle and cos of the same angle, that is sine square A plus cos square A. Remember, when I write sine A the whole square, it means sine square A, and it does not mean sine A the whole square. That does not mean sine A the whole square. Okay, sine A the whole square, I'm sorry, it does not mean sine of A square. Sine of A square means sine of A square means sine of A multiplied by A. Sine of A multiplied by A is sine of A square. Okay, sine square of A, is sine A multiplied by sine A. Sine square of A is sine A multiplied by sine A. Okay, so remember that sine A the whole square and sine square A are the same thing, that is sine A square. Sine A multiplied by sine A. But sine A square is sine of the angle A multiplied by angle A. That is the square of the angle. So that is completely different. And we don't come across that in any of the square relations. Okay. So sine square A is BC by AC the whole square and cos square A is AB by AC the whole square. And if you solve this as BC square plus AB square is AC square by Pythagoras theorem, you get 1. So sine square A plus cos square A is 1. Now, since sine square A plus cos square A is 1, you can say that 1 minus sine square A is equal to cos square A and 1 minus cos square A is equal to sine square A. right? So these two are, you can say, uh, further derivations of sine square a plus cos square a is identity. Okay, so sine square a plus cos square a is 1 means 1 minus sine square a is cos square a, and 1 minus cos square a is sine square a. Next is 1 plus tan square a. 1 plus tan square a is equal to sec square a. Please remember, 1 plus tan square a. So we have put the value of tan a simplified and we have got sec square a. So 1 plus tan square a is sec square a, or you can say that sec square a minus 1 is equal to tan square a. Or you can also say that sec square a minus tan square a is equal to 1. So these three are, you can say, the square relation of tan and sec, and this one, the first one, is the primary identity which you need to remember so that you can derive the second and third one. Okay, similarly over here, this is the primary identity and these two can be derived from it. There is one more square relation. 1 plus cot square a is equal to cosec square a. Okay, which means that cosec square a minus 1 is equal to cot square a, and cosec square a minus cot square a is equal to 1. Cosec square a minus cot square a is equal to 1. All right, so we have now the square relations as you can see over here. Great. So, uh, all the square relations, reciprocal relation, quotient relations, trigonometrical ratios, their format, their formula, everything is in front of you. You have to use only this much information to solve trigonometrical identities, and I'm going to show you how to solve these trigonometrical identities with the help of solved examples. And then there are few more variations, or you can say advanced kind of questions which we will solve in part B. Part C is about trigonometrical ratios of complementary angles. Very simple, very easy part. That's also we are going to have a look at. And the fourth part is about trigonometrical tables. Okay, so we'll try to do part number 1 and 2 in the same video and in this video, and part 3 and 4 will cover in the next video. Okay, so let's begin with part A of trigonometrical identities. Okay, so what we have to do, we have to prove this trigonometrical identities. Let's do it. Okay, so we have to prove this identity. I hope all of you can see I have not made the font very small. I'll just make it a little big. Okay, great. So we have to prove this identity. Tan a plus cot a is equal to sec a times cosec a. Okay, so to prove the identity, to prove any identity, we have to take either LHS or RHS, convert it into simpler forms, and make it equal to the LHS or the RHS. I'll show you how. I'm going to show you so many examples and you will get a hang of this whole method by the end of it. So we'll start with LHS or RHS. Okay, let's start with LHS and show you. LHS is equal to tan A plus cot A. Now I have to make this tan A and cot A into sec A and cosec A. Okay, so I can use reciprocal relations, quotient relation, square relation, whichever relation I feel that I can use to simplify this particular equation, I will use. Okay, so let's first see the simplest way of solving any trigonometrical identity is to convert your given trigonometrical ratios in the form of sine and cos. Okay, so tan A is sine A by cos A and cot A is cos A by sine A. Now we'll take LCM and then add it. So we get sine square A plus cos square A the whole upon sine A cos A. Sine square A plus cos square A is 1. Sine square A plus cos square A is 1 upon sine A cos A. 1 upon sine A is cosec A and 1 upon cos A is sec A. So 1 upon sine A cos A is cosec A sec A or sec A cosec A, however you want to write. It is the RHS. So I converted LHS into RHS. How? By applying the relationships between the trigonometrical ratios using reciprocal relations, square relations. I have to convert the LHS into RHS. This is the whole, you can say, concept of trigonometric identities. This is what you have to master. Okay, so we will see more examples and we'll try to understand how we can make this concept easy. Okay, so there are 3 questions over here. Number one, we have to convert cos raised to 4a minus sine raised to 4a into 2 cos square a minus 1. Into 2 cos square a minus 1. Okay, let's see how to do it. So I'm going to start with the RHS this time. RHS is 2 cos square a minus 1. Okay, so this will be 2 cos square a minus cos square a plus sine square a. 1 is cos square sine square a plus cos square a, right? So in the place of 1 I wrote this. Now this will become 2 cos square a minus cos square a minus sine square a, which will become 2 cos square a minus cos square a is cos square a minus sine square a will remain sine square a. So I got cos square a minus sine square a. Okay, now what do I want? I want cos 4a minus sine 4a. And I got cos square a minus sine square a. So I will take LHS and I will solve it now and I will convert it into cos. It is given that cos LHS is equal to cos 4a minus sine 4a. Okay, so this is cos square a the whole square minus sine square a the whole square. That is equal to cos square a plus sine square a multiplied by a square minus b square is a plus b into a minus b. Cos square a minus sine square a. Cos square a plus sine square a is 1. So we'll be left with cos square a minus sine square a. So as you can see, your RHS and your LHS both are equal to cos square a minus sine square a. You could have started with LHS also and then you could have taken RHS and simplified it. Correct? This way is also fine. Any way is fine. Only idea is to make your LHS equal to your RHS. That's the only thing which needs to be done. Let's do the second question. One plus cot A the whole square plus 1 minus cot A the whole square is equal to 2 cosec square A. 2 cosec square A. Let's start with LHS left hand side because I think left hand side is a little bit complicated, so it can be simplified. So 1 plus cot A the whole square plus 1 minus cot A the whole square. I will apply the identity a plus b the whole square and a minus b the whole square. I'll get 1 plus 2 cot A plus cot square A plus 1 minus 2 cot A plus cot square A. This will get cut and I'll get 2 plus 2 cot square A. 2 will come out common and I'll get 1 plus cot square A. 1 plus cot square A is cosec square A if you remember the square relationships. So 2 cosec square A, which is equal to your RHS. That's it. Easy? You feel it's easy? If you feel it is easy, very good. That means you are getting some idea about how to solve the problems based on trigonometrical identities. But if you're not getting any idea till now, then I think you should take some time and try to understand each and every question in detail. So if you want, you can watch this video again till you understand, okay, oh, this is the way uh, I'm solving it, or this is what needs to be done. If you get that knack, if you get the knack of the technique, you can solve it easily. Next question. Tan 4a plus tan square a is equal to sec 4a minus sec square a. Okay, this is easy question. I'll take LHS. Of course, square relations has to be used. Tan 4a plus tan square a is equal to, what I'm going to do is I'm going to take out tan square a out common, and inside I'll be left with tan square a plus 1. Now 1 plus tan square a is sec square a. So tan square a bracket sec square a. Now I'm going to convert this tan square a into sec square a. Now 1 plus tan square a is sec square a. So tan square a is sec square a minus 1. Sec square a minus 1 bracket sec square a, which is already there. So we'll multiply sec square a inside, it will become sec 4a minus sec square a, which is your RHS, right hand side. Easy. So all the three questions are solved. Now you have got a good idea about what is trigonometrical identities, how to solve the questions based on trigonometrical identities, and this idea will become more and more clear as we go ahead. Okay, question number 3, part 1. So in part 1, you see, okay, there is one issue with part 1 LHS denominator of the first term. It's written 1 is equal to cos A. Let's check what is the actual question. Part 3, question number 1 and 2, denominator. Part 3, question number 1 and question number 2, denominator. In the first denominator we have plus, in the second denominator we have minus. All right, so this one is plus and this is minus. Okay, great. Now as you can see, the first part of question number 3, it says sine A, prove that sine A upon 1 plus cos A plus 1 plus cos A upon sine A is equal to 2 cosec A. Out of your LHS and RHS, which one seems more simpler? RHS is more simpler. We cannot simplify it further, but we can simplify LHS because it's more complicated. So I'm going to start with LHS. Sine A upon 1 plus cos A plus 1 plus cos A the whole upon sine A. Okay, so this will become, okay, so now we are taking LCM. So this will become sine square A plus 1 plus cos A the whole square, the whole upon sine A bracket 1 plus cos A. Sine square A plus 1 plus cos A the whole square, the whole upon sine A bracket 1 plus cos A. Let's simplify this. So we have sine square A plus 1 plus cos square A plus 2 cos A, the whole upon. So I've just expanded this using A plus B the whole square, the whole upon sine A bracket 1 plus cos A. I'm not going to open the bracket. I think that I can simplify it before that. Sine square A plus cos square A is 1, right? Sine square A plus cos square A is 1. 1 plus 1 is 2. 2 plus 2 cos A, the whole upon sine A bracket 1 plus cos A. So 2 bracket 1 plus cos A, the whole upon sine A bracket 1 plus cos A. So we get 2 upon sine A, which is nothing but 2 upon cosec A. Why? Because 1 upon sine A is cosec A. Sine A is the reciprocal of cosec A, or cosec A is the reciprocal of sine A. So that's your RHS. Right? So that's the first question. Let's go to the second question. I hope you're noting it down. I will suggest that once you see the question, how it is solved, you pause the video and you solve it yourself. When you solve it yourself, you get the confidence. If you don't understand what to do next, it's very simple. What you do, you simply look at the video again, try to understand what was your mistake, rectify the mistake, and try to solve yourself all over again. That will get you a good amount of confidence to solve the questions in the exercise. That's the whole idea. Okay, question number 2. I'll start with LHS. 1 plus cos A upon 1 minus cos A. So if I want to simplify this, there is one easy way. Whenever you see some some expression of the term of the form A plus B upon A minus B, always choose to simplify this kind of expression by multiplication of conjugates. I'll show you what is multiplication of conjugates. So what you have to do is you have to multiply 1 plus cos A in the numerator and denominator so that the equation gets simplified. Okay, so now this will become 1 plus cos A the whole square upon 1 minus cos A, 1 minus cos square A, 1 minus cos square A. Okay, so this will become 1 plus 2 cos A plus cos square A, the whole upon 1 minus cos square A is sine square A. Okay, now there is no point of simplification of this expression further, so I'm going to solve RHS. So RHS is cosec A plus cot A the whole square. So you can convert cosec A and cot A in terms of sine and cos. So cosec is 1 upon sine A and cot A is cos A upon sine A the whole square. So this will be 1 upon sine A the whole square plus, okay, wait, you can simplify this by taking an LCM. There is no need to take LCM, but you can simplify it like this. 1 plus cos A the whole square upon sine square A. So 1 plus cos A the whole square is 1 plus 2 cos A plus cos square A the whole upon sine square A. 1 plus 2 cos A plus cos square A the whole upon sine square A. And that exactly matches with your LHS. Now if you check your LHS and RHS, they both are exactly the same. Do you see that? Okay, let's move on to the third question. Okay, the third question says cot A plus tan A upon cot B plus tan A. Cot A plus tan B upon cot B plus tan A is equal to cot A tan B. So the tricky part over here I felt is A and B. Cot of angle A, tan of angle B. So that's a tricky part, but we can simplify this. Let's start with the LHS. So LHS is cot A plus tan B the whole upon cot B plus tan A. Cot A. Okay, so what I'm going to do is, since I don't want tan A, I'm going to convert tan A into cot A. And I don't want cot B. I don't want cot B. So I'm going to convert cot B into tan B. Right? So the numerator will remain as it is. Cot A plus tan B. But the denominator will become 1 upon tan B plus 1 upon cot A. Okay, so this will become cot A plus tan B the whole upon cot A plus tan B the whole upon cot A tan B. I will shift this to the numerator, so it will become cot A plus tan B multiplied by cot A tan B the whole upon cot A plus tan B. Okay, so we are left with cot A tan B, which is your RHS. So LHS is exactly equal to RHS. So that was simple, easy. Let's go to the fourth question. Fourth question has LHS, left hand side, equals cos A cot A the whole upon 1 minus sine A. Cos A cot A the whole upon 1 minus sine A. Okay, I have to convert it into 1 plus cosec A. Let's convert everything in terms of sine and cos. So cos A multiplied by cos A upon sine A the whole upon 1 minus sine A. So that is cos square A the whole upon sine A bracket 1 minus sine A. So cos square A is 1 minus sine square A the whole upon sine A bracket 1 minus sine A. 1 minus sine square A will be 1 plus sine A, 1 minus sine A the whole upon sine A bracket 1 minus sine A. 1 minus sine A gets cancelled. I get 1 plus sine A upon sine A, which can be written as 1 upon sine A plus sine A upon sine A. Sine A gets cancelled. So we have 1 upon sine A, which is cosec A plus 1, which is your RHS, right hand side. So that was your fourth question. Okay, so you are getting a lot of exposure on how to solve trigonometric identities. Let's get some more idea. Okay, one very interesting question is coming up. Question number 4. Prove that sec A minus tan A upon cosec A plus cot A is equal to cosec A minus cot A upon sec A plus tan A. So this question has been solved in a very peculiar manner in your textbook. Okay, so I'm going to discuss that manner first, the method of textbook, and then I'm going to do it by some other method as well. So if sec A, see, I'm not starting with LHS, that's the difference. If sec A minus tan A upon cosec A plus cot A equals cosec A minus cot A upon sec A plus tan A. If this is equal, if LHS is equal to RHS, then sec A minus tan A multiplied by sec A plus tan A is equal to cosec A minus cot A bracket cosec A plus cot A. So this gives sec square A minus tan square A, you can write then, equals cosec square A minus cot square A. Then sec square A minus tan square A is 1 and cosec square A minus cot square A is also 1. So 1 is equal to 1, which is true. Hence, proved. Okay, so what we have done is, if LHS is equal to RHS, then if you cross multiply them, then the product should also be equal. Then the cross multiplication product both becomes 1. So 1 is of course equal to 1. So if 1 is equal to 1, then of course LHS is equal to RHS. Okay, so that's one method of doing it, one way of doing it. The other way of doing it I'm going to discuss with you. So what I'm going to do is I'm going to start with LHS. LHS is sec A minus tan A upon cosec A plus cot A. And I think you can guess what I'm going to do next. What I'm going to do is I'm going to convert this LHS, all the terms of LHS in the form of sine and cos. In the form of sine and cos. So sec is 1 upon cos A minus tan is sine A upon cos A, the whole upon 1 upon sine A plus cos A upon sine A. Okay, so this will become 1 minus sine A upon cos A, the whole upon 1 plus cos A upon sine A. So sine A gets multiplied with 1 minus sine A and cos A gets multiplied with 1 plus cos A. Now this looks little difficult to simplify because sin A upon cos A is tan A. I can very well write tan A and leave it as it is, tan A times 1 minus sin A upon 1 plus cos A. But simplifying it further does not make any sense as of now. Even if I would multiply this sin A inside, so I'll get sin A minus sin square A. Okay, and sin square A could be written as 1 minus cos square A. But then the complications would continue, it would not end. So what I'm going to do is I'm going to try simplifying RHS now, which is RHS is cosec A minus cot A upon sec A plus tan A. Cosec A minus cot A, cosec A minus cot A upon sec A plus tan A. Cosec A minus sec A, sorry, cosec A minus cot A upon sec A plus tan A. Okay, let's check. Cosec A is 1 upon sin A minus cot A is sin A upon cos A. The whole upon sec A is 1 upon cos A plus tan A is sin A upon cos A. Okay, so this will be, wait, cos A, I'm sorry, I made a mistake over here. Cos A is cos A upon, again I'm making the same mistake, cos A upon sin A. Yeah, so this will be 1 minus cos A upon sin A, the whole upon 1 plus sin A upon cos A. So this will go up, this will come down, and I'll get cos A multiplied by 1 minus cos A, the whole upon sin A multiplied by 1 plus sin A. Okay, now if you compare your LHS and RHS, they look like reciprocal of each other with opposite signs. They look like reciprocal of each other with opposite signs. Okay. Any way to simplify this? No. So LHS and RHS, solving LHS and RHS does not lead you anywhere until and unless you are ready to simplify things and convert one form into another. Okay, so that I don't think it's possible. So the previous method which I showed you, you can stick to that method. You can stick to this textbook method for that, right? Let's go to the next question. Now the questions are becoming little trickier. Okay, here the only difference is that we do not have this root. This root does not exist. The root is only up to over here. Okay. So under root of 1 minus sin A upon 1 plus sin A is equal to sec A minus tan A. Sec A minus tan A. Okay. So the left hand side is one minus sin A upon 1 plus sin A. This is the left hand side. Now, as I told you earlier, we can do rationalization in this. Okay. So for that, I'm going to write it as under root of 1 minus sin A upon under root of 1 plus sin A multiplication with a conjugate. multiplied by under root of 1 minus sine A upon under root of 1 minus sine A. Okay, so this will be under root of 1 minus sine A the whole square Okay, so we just multiplied all the terms inside the root. Okay, so the next step will be, I'm just going to cut this square and the square root. So I'm going to write it as 1 minus sine A the whole upon 1 plus sine A multiplied by 1 minus sine A is 1 minus sine square A. 1 minus sine square A is cos square A. So 1 minus sine A the whole upon cos A. 1 minus sine A the whole upon cos A can be written as 1 by cos A minus sine A by cos A. 1 minus cos A is sec A and sine A by cos A is, right? So LHS is equal to RHS, right? So this is very easy. Let's go to the next question before we start the part B. This is the last question, and I think that's the most important question, the last one. I'm going to start with LHS in the last question. Tan A plus sec A minus 1 the whole upon tan A minus sec A plus 1. Okay, so here we are going to try something very, very unique. What we are trying to do over here is we are trying to simplify this fraction by substituting the value of 1. Now, do you remember a square relationship with tan, sec and 1? 1 plus tan square A is equal to sec square A, or sec square A minus tan square A is equal to 1. Sec square A minus tan square A is equal to 1. So I will replace the value of 1 in the numerator, tan A plus sec A, and in the place of 1 I'm going to write sec square A minus tan square A. Sec square A minus tan square A. Now note very carefully what I'm going to do. Tan A minus sec A plus 1. So this will be tan A plus sec A minus sec square A minus tan square A will be sec A plus tan A multiplied by sec A minus tan A. Okay, so this will be in the bracket, the whole upon tan A minus sec A, tan A minus sec A plus 1. Alright, so what we are going to do is we are going to take out these two terms, that is sec A plus tan A, out common. So we'll be left with tan A plus sec A one minus, okay, so tan A plus sec A comes out. In the place of tan A plus sec A over here we get 1 minus sec A plus tan A comes out. I'm getting, okay, when I open the bracket there is a minus sign outside, so I'm getting minus sec A plus tan A the whole upon tan A minus sec A plus 1. So what happens is now this two terms get cut and I am left with tan A plus sec A. Tan A plus sec A. Okay. Wait, I had to prove sec A minus tan A, and I'm getting tan A plus sec A. Wait. Let me check my method, please. Hey, what am I reading? Actually, I have to prove it equal to 1 plus sine A by cos A. I was seeing over here. This is what I need to prove. Okay. So tan A plus sec A, I'm left with tan A plus sec A. Let me simplify this further. Okay. So tan A is sine A by cos A plus sec A is 1 by cos A. So I'll get 1 plus sine A by cos A, which is your RHS. 1 plus sine A by cos A, which is your RHS. Okay, so we have proved that LHS is equal to RHS. This is a unique method in which we replace 1. We substitute the value of 1 and then we factorize and then we get the answer in, let's say, 4 or 5 steps. So you will find the same question in the exercise. I just want to show you. So there are alternative methods also. In the other method, they have converted everything in terms of sine and cos, and that's more complicated. So don't do that method. Okay. In your exercise also, you will find a similar question, which is let me show you. There are so many questions in the exercise. You will find similar questions. You will have doubts. Yeah. So the similar question you will find in exercise is 46th. Okay, but unless and until you get after a question, even if you're not getting, try different methods, you will eventually get the answer. Right? So that was the first part of the chapter. Let's okay, 1 hour of the video is up. Okay, let's do one thing. What I'm going to do is I'm going to make another video. 1 hour is up. Yeah, I think I need to edit some parts, so 1 hour is not up. Let me continue with the video. Let's start with the second part. Okay, part B. So we have more trigonometric identities. Let's start. Okay, LHS. We have cos A upon 1 minus tan A plus sine A the whole upon 1 minus cot A, and we have to convert it in terms of cos A plus sine A. Very easy. So cos A upon 1 minus sine A upon cos A plus sine A the whole upon 1 minus cos A upon sine A cos A minus sine A upon cos A plus sine A upon sine A minus cos A upon sine A. Okay, so we have cos square A the whole upon cos A minus sine A, plus we have sine square A the whole upon sine minus cos A. Okay, we are going to do some small change over here. Cos square A upon cos A minus sin A minus sin square A upon cos A minus sin A. So this sin A minus cos A has been transformed into cos A minus sin A, and I took out minus common, which converted this plus into minus. Okay, so I can now write it as cos square A minus sin square A, the whole upon cos A minus sin A. Now cos square A minus sin square A is cos A plus sin A times cos A minus sin A. The whole upon, we get cos A minus sin A over here. So cos A minus sin A gets cut and we are left with cos A plus sin A, which is your RHS. Cos A plus sin A, which is your RHS. Right, so that's question number 6, part 1 for you. Let's do the second part. All right. So we have in LHS 1 plus tan square A plus 1 plus 1 upon tan square A okay, 1 plus tan square A can be written as sec square A plus this, we can take LCM and write it as 1 plus tan square A upon tan square A. So sec square A plus sec square A by tan square A. Okay, sec square A can be written as 1 by cos square A plus sec square A by tan square A. So I can write it as 1 by cos square A, the whole upon sin square A by cos square A. Okay, cos square A comes down, cos square A goes up over here. So we get 1 by cos square A plus cos square A, just a moment, cos square A upon cos square A sin square A. Okay, so here this cos square A will get cut. So we get 1 upon cos square A plus 1 upon sin square A. So we take LCM, we get sin square A plus cos square A, the whole upon cos square A sin square A. Okay, so that is 1 upon cos square A sin square A. So we want to get everything in terms of sine, right? So this will be 1 upon, see this cos square A will become 1 minus sin square A, the whole into sin square A. So this will be 1 upon sin square A minus sin 4A, and that is your RHS, 1 upon sin square A minus sin 4A. Right, so first I converted tan in terms of sec, here also tan in terms of sec, then I converted sec and tan both in terms of sine and cos, simplified it, taken LCM, simplified again, converted cos in terms of sine, and then simplified to get the final answer. So that's your question number 2 of part B. Sub question 2, question number 6, part B. Question number 7. Very interesting question. This is of the type of eliminating trigonometric ratios. So if tan A plus sine A is equal to m, if tan A plus sine A is equal to m, and tan A minus sine A is equal to n, prove that m square minus n square is equal to 4 under root mn. M square minus n square is equal to 4 under root mn. Okay, so LHS is m square minus n square. Okay, what is m? Tan A plus sine A the whole square minus tan A minus sine A the whole square. Okay, so what I'm doing is I'm trying to simplify LHS separately and RHS separately. Okay, so let's square it. Tan A plus sine A the whole square, which will be tan square A plus 2 tan A sine A, tan A sine A, plus sine square A minus bracket tan square A minus 2 tan A sine A plus sine square A. Okay, I'll open the bracket. It will become tan square A plus 2 tan A sine A plus sine square A minus tan square A plus, see, all the signs inside the bracket will change, plus 2 tan A sine A minus sine square A. Now if you see, tan square A minus tan square A will cut, sine square A minus sine square A will cut, 2 tan A sine A plus 2 tan A sine A will become 4 tan A sine A. 4 tan A sine A. Okay, so that's, I think, by far we can reach with LHS. So now we have to solve the RHS. Hey, we can go one more step ahead and we can write tan A as sine A by cos A multiplied by sine A. So 4 sine square A by cos A. I think you can't go farther than this. So either this or this. Anything will work as the simplified form of LHS. Now let's talk about RHS. So what is your RHS? RHS is 4 under root mn, which is 4 under root tan A plus sine A multiplied by tan A minus sine A. 4 under root tan A plus sine A multiplied by tan A minus sine A. Okay, so this will become 4 under root tan square A minus sine square A. A plus B into A minus B is A square minus B square, which is 4 under root tan square A is sine square A by cos square A minus sine square A. Okay, so this is 4 under root sine square A minus sine square A cos square A the whole upon cos square A. 4 under root sine square a bracket 1 minus cos square a the whole upon cos square a 4 under root. Okay, so what I'm going to do is I'm going to convert this 1 minus cos square a into sine square a. So this will be sine square a multiplied by sine square a the whole upon cos square a. Okay, so this becomes 4 under root sine 4a upon cos square a. So this will become 4. This will be written as 4 sine square a upon cos a, which is your LHS. Therefore, LHS is equal to RHS, hence proved. 4 sine square a by cos a, both are simplified. Okay, please note it down. This is an interesting and important question because in the end, the LHS and RHS should be equal, and what we have to prove does not have any trigonometric ratios. So trigonometric substitution works over here. This is also similar kind of question. We have been given the value of x, y, and z. So x is equal to a sec a cos b. Y is equal to b sec a sin b. And z is equal to c tan a. Okay, so we have to show that x square by a square, x square by a square plus y square by b square minus z square by c square equals 1. So we'll just substitute the value of x, y, and z. Okay, so x square, that is a sec a cos b the whole square by a square plus y is, let me make some space, y is b sec a sin b the whole square by b square plus z or z is c tan a the whole square by c square. So this will give you a square sec square a cos square b by a square plus b square sec square a sin square b the whole upon b square by c square tan square a by c square. C square gets cancelled, b square gets cancelled, a square gets cancelled. Okay, now if you see, you have sec square a cos square b plus sec square a sin square b. Take out sec square a common, you get cos square b plus sin square b plus tan square a. So sec square a times 1 plus tan square a is sec square a plus tan square a. Just a moment. Yeah, I found my mistake. There was a small mistake I did here is minus. Okay, so this is minus. So this is minus, this is minus, this is minus, and this is minus. So sec square a minus tan square a is equal to 1. Sec square a minus tan square a is equal to 1. All right, so that's your question number 8 simplified. Please note it down properly. First understand everything and then solve it by yourself. If you don't understand, please watch the video again. Okay, so we are already on part C. Great. So I'm going to cover part C and part D in the next video. In the meanwhile, you just watch this video and try to, properly understand what I have taught. And I'm going to see you in the next class. Bye bye.